With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start the question. The question says that in a series resonant LCR circuit, the capacitance is changed from C to 3C for the same resonant frequency. The inductance should be changed from L to the value. So let's try to understand what's a series resonant LCR circuit, and then we will talk about the resonant frequency. So series LCR circuit is a very important circuit which is used in AC filters, noise filters, radio and television tuning circuits, such that it will help us in selective tuning of the given circuit over the different frequency channels. So let's analyze this LCR circuit. So if at all I'm considering a series LCR circuit, as the name suggests, there should be a resistor, capacitor and an inductor connected in series, and there is an AC voltage applied to this. So the AC voltage which we are going to apply will have a peak value of V0. So whatever voltage I am going to apply, V is equal to V0 sine omega t. The resistance is R, capacitance is C and inductance is L. So since they are connected in series, same amount of current flows through all of them, but the voltages are different. This will be VR, VC and VL, such that whatever applied voltage is there, that should be equal to VR plus VC plus VL. But now we know that whenever AC flows through a resistance, there is no phase difference between the current and the voltage. Whenever it flows through a capacitor or an inductor, there is a phase difference of 90 degrees between your current and voltage. Due to that, apart from the resistance offered by the resistor, there is also a resistance offered by our capacitor and inductor. The resistance offered by capacitor is known as capacitive inductance. So it is written by capacitive inductance and it is given by XC, which is given by 1 by omega C. In terms of frequency, we can write it as 1 by 2 pi FC. Similarly, we have inductive reactance, that is the resistance offered by our inductor, called as inductive reactance, and it is represented by XL, which is equal to omega times L, which is 2 pi Fl. So whenever XL is greater than XC, the capacitive is the circuit is inductive. When XC is greater than XL, the circuit is capacitive. So if at all we are talking about the total reactance of the circuit, the total reactance will be the difference between the capacitive and the inductive reactance, and the total impedance in the circuit, that is the resistance in the circuit, is given by square root of R square plus XL minus XC the whole square. So this will be the impedance in the circuit. So we know that the capacitive inductance is also depending on frequency, and the inductive reactance is also depending on frequency, wherein inductive reactance increases with frequency and capacitive reactance. So capacitive reactance decreases with the increase in frequency. So for this variation of your capacitive reactance and inductive reactance with frequency, so in a given AC circuit, as these two effects of the reactances, that is capacitive reactance and inductive reactance, cancel out each other, there will be a frequency for which they cancel out each other. That frequency wherein the total resistance of a circuit is just depend upon the resistance of the circuit and not on the capacitive reactance and the inductive reactance, that particular frequency is called as resonant frequency, and resonant frequency occurs at the condition will be when capacitive reactance cancels out inductive reactance, and that particular frequency is called as resonant frequency. We know what is XL, which is nothing but 2 pi FL, and XC is equal to 1 by 2 pi FC. So we need frequency, let's cross multiply it to the other side, F square. Since it is resonant, let's call it as FR. FR square will now be equal to 1 by 4 pi square LC. Taking square root on both sides, my resonant frequency will be equal to 1 by 2 pi whole under root 1 divided by LC. So this is a condition wherein resonance occurs. So resonance occurs when the effect of the reactances cancel out each other. So in this particular series LCR circuit, total resistance in the circuit will just be governed by our R. So now in the given question, they say that in the series LCR circuit, capacitance is changed from C to 3C. What should be L changed from such that frequency remains the same? So since frequency is remaining the same, FR should be equal to 1 by 2 pi. In the first case, it is changed from C to 3C. This will be under root 1 divided by LC, and FR will be equal to 1 by 2 pi whole under root 1 by L dash C dash. Since frequency is remaining same, this will be 1 by 2 pi under root 1 by LC. That should be equal to 1 by 2 pi whole under root 1 by L dash C dash. Cancelling out the like terms, squaring on both sides, LC will be equal to L dash C dash. We need to find out what is L dash. L dash will now be equal to LC divided by C dash. So this is nothing but LC divided by 3C. CC goes away. Therefore, inductance has to be changed from its original value to 1/3 of its value. So L will be changed from L to L by 3, and hence the correct option will now be equal to option 2. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.